Okay, we're in section 95. Contents for you to look at, examples for you to try to comprehend from the contents, and then getting busy with the exercises. All right. So my name is Ron Bannon. It's a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, which dates back to 1904. It's old. It's still a great course, though. Certainly has many great problems in it. However, history has changed somewhat. So this is a document that's being made available to the Prison Mathematics Project participants. I realize other people may be watching these videos, and they may be interested in coming up with the actual PDF that I'm sharing with the Prison Mathematics Project participants. It's not published yet, but it will be published. My name is Bannon. My email address is also Bannon. Whoops, let me get my little pen out. That's B as in boy, the @ symbol, nnon.us. All right? So the bottom line here is if you do need to reach out to me, use that email address. If I'm overwhelmed, I may not be able to get back to you, but I try to get back to people that actually email me, all right? Sometimes I just thank them for sharing things with me. Sometimes I let them know if there's a publication date. I'll keep a list of you, and I'll try to update you about when your publication date comes and where to get the document. All right, so what I'm going to do now is I'm just going to, I wonder what this is all about. It's going forward. But then it's just logarithm stuff. And just to give you a little historical perspective here, logarithms were a massive achievement in computation. They allowed people to do computing very quickly. And again, what you needed back then was not a computer. You needed a log table, and you need to understand how logs worked. All right? Now, I got to be honest with you, logs now are not used for computational purposes. There's other purposes for logs. But right now, I'm not worried about it. What I'm worried about is, can I understand what Wells is presenting in logarithms? It's a tough section again. But again, I would recommend you read through that, try to make some sense of what you're reading, and move forward. All right? Now, my intent is hoping that you've read this, you had some, basic understanding of what you've read, and you're ready to get moving. And I want to claim that there's really 3 really important rules. Oops, I did it again. Let me just back out. Okay, these are basic rules of logs. Product rule. For any positive number m and n, and any logarithm base a, this will be a true statement. So someone said, what's being accomplished there? They're looking at a product and they're writing it as a sum. And that's an important achievement right there. The next one, power rule. It states that for any positive number n and any logarithmic base a and any real number p, that you have this relationship. What's been accomplished here? Well, they're taking a power, which is very difficult to deal with, and writing it as a product. That's pretty important. Next up, subtraction rule. Again, any positive numbers m and n and any logarithmic base a. The log of a quotient is the difference of the logs. This is really important. Now, by the way, I'm not going to bore you with my hand arithmetic, but realize when Wells wrote this book, it was hand arithmetic. So what they want me to do, they want me to use the givens. By the way, you're not to determine if these givens are true or not, but these are given. In other words, Wells looked those up in a table, and that's what they were given. From those given, they want you to approximate this log over here. All right? Now, I got to be honest with you, Wells was rather, cavalier with equal signs. Like, he'd often write down things like this: log base 10 of 2. He'd put an equal sign over there. He'd write this over here. This simply is not true. All right? That's why I use those squiggly little lines over there. What am I saying? It's approximately equal to that. All right, let's get back to the real story, though. And this could be log. It's a base 10 log, by the way. That doesn't matter to me. But I'm going to write this over here. And what I got to get that 72 in terms of 2s and 3s. Well, let me write this down for you. 72 divided by 2 is 36. Let's keep going. 2 into 36 is 18. 2 into 18 is 9. And they get 3 and 3. So I'm going to say log, 2 cubed times 3 squared. And I'm going to now use that product rule. What are you going to get? This would be the same thing as log 2 cubed plus log 3 squared. I just used that product rule. Now I'm going to use this power rule. What are you going to get over here? 2, I'm sorry, not 2. I made a mistake there. Daydreaming again. I daydream a lot, by the way. It's going to be 3 times the log of 2 plus 2 times the log of 3. Now, by the way, I'm really not interested in doing the arithmetic, but this will be approximately equal to 3 times, well, what's the log of 2? It's this number over here, 0.3010 plus 2 times, and what's the log of 3? This number over here, 0.4771. I do the arithmetic for you. I want to put this stuff is written down for a reason. We'd like you to look at it. I do believe you should use a handheld calculator to do that. I got to be honest with you, though. Nowadays, if we want to know the log of 72, I would just use a calculator to approximate it. I would not go through this rigmarole to do it. It just wouldn't happen. All right, let's do this one more. We're just trying to, basically use, if we know the rules, by the way. So they said, given this, find this. That looks tough, though, doesn't it? I mean, how would 5 be related to 2? Well, let's take a look at it. So I'm going to say log of 5 is the same thing as log. Well, how would I get that to be a 2? Well, I'm looking at it. I'm going to say 10 divided by 2. That's the same thing. Now, what I'm going to do, that's a quotient, right? So I'm going to put log, and these are base 10 logs, 10 minus log 2. All right? And that's log 5. I get troubles, though. They didn't tell me what the log base 10 of 10 is, but they did tell me that the log of 2 was approximately this number over here. That's why I'm using the approximate symbol. This is something Wells is not big on doing. All right, I got to talk about this log base 10 of 10, and I'm going to say I don't know what it is. I'm going to call it x. So what's that going to be? Well, I got to rewrite it as an exponential, so 10 would equal 10 to the x. Well, clearly x is 1. All right? Again, I'm not interested in doing the arithmetic, but the arithmetic's over here for you. Let's do the next one. And this one over here, they want to know the log of 2 to the 5/3. Well, what they're doing is they're giving me this, and they want this. So I got to get the thing they want in terms of the thing they've given me. Well, I'm going to use power rule. So log, this is base 10, by the way, 2 to the 5/3 is the same thing as 5/3 times the log of 2. This is approximately the same thing as 5/3 times the log of 2 is 0.3010. Again, that stuff's written over here for you. Again, I'm not interested in the arithmetic. The arithmetic over here. If I really didn't know the log of that, I think I just use a calculator to get the log of it. All right? Let's do this one over here. And again, it's really what's given. This is given. Whoops, sorry about that. This is given. This is their want. Let's write this down. So log the 8th root of 3. That's a really tough number, by the way. But this is the same thing as log of 3 to the 1/8. 1/8, by the way. What is this equal to? 1/8 times the log of 3. Do I know the log of 3? Approximately, I do. So 1/8, what's the log of 3? This number over here. Now again, in Wells' time, the students will be expected to do the arithmetic. I'm just writing down what the arithmetic is. That's all I'm doing, all right? So it's 1/8 times 0.4771. All right, so they give me this, and they gave me that. They give me an approximation. And then what they want me to do, and this could be difficult, I'm not saying it's going to be easy for you. They want the log. I'll write down what they want. They want the log of this. So let's write it down. And I got to get in terms of those things they've given me. So the log of 2 to the 1/3 times 3 to the 5/4 is going to be, I'm getting a little better at this, it's going to be 1/3 log of 2 plus 5/4 log of 3. This is approximately the same thing as 1/3. The log of 2 is given to me as 0.3010 plus 5/4, and the log of 3 has been given to me as 0.4771. All right, the arithmetic's written over here, and again, if you did the arithmetic, you get this thing over here. All right, so again, logs historically were used for doing arithmetic, but we don't see that yet. All right, we'll get to there eventually. But here's the deal. You got exercises where the exercise is going to be very similar to what we just did over there. Go through it. You're going to learn a lot about logs by doing it. But the bottom line is, I know it's difficult. We're suggesting that you can do it. All right? Now, by the way, when they say approximate the value of these logs over here, you're using something. And what are you using? You're using this stuff over here. I want to point out, these problems, you're going to be using this stuff over here. These are the givens. You want to use those to do all these problems over here. So you start to realize that these numbers that they're giving you are related to the given numbers. They should be. If they're not, there's trouble. They should be related to the given numbers. Even this crazy looking guy, related to the given numbers. Now, why is that? They're being kind. Right? They're not asking for anything outside their kindness. All right? A lot of problems. Get through them. I know it's difficult. Yes, I did all the problems. Maybe I made an error. If you think I made an error, bring it to my attention. I really mean that. Why do we do a lot of problems? To learn. That's why we do problems. Okay, get to the SAGE. What's SAGE? Computer Algebra System. It's a CAS stands for Computer Algebra System, open source. Go to this website. You can either download interactive web application, and you might want to take a look at logs. All right, try to understand what's going on here. Here's the deal, though. I'm really not interested in SAGE. What I'm interested in, you being able to do some handwork. What kind of handwork are we asking to do? What Wells is expecting of us. My email address, if you see any errors or you have any concerns about what's written down in my document, please reach out to me. I'm looking forward to it. And by the way, that doesn't look right to me. I'm going to erase it. All right? That's U for U.S. All right? I'm in the United States. Thank you for paying attention.